All right, you guys ready? Last day. My voice is back though, so that's cool. So this, I think this is probably the hardest for students, network automation, the programmability piece. With the new v1.1 updates, we only have to go over Ansible and something called Terraform for as far as languages we gotta know. In your smart book, I put Python because right when you go to CCNP, they make you learn it. But that is like probably the most diverse network automation language because of the libraries that you can use. Really at CCNA, we're trying to understand why we do network automation, what programmability is. We're not actually configuring or automating networks, okay? If you want to learn how to do that stuff and like tie it to a cert, you can come to our CCNA DevNet class. That's where we get into actually doing API requests, calls, gRPC, things like that. So let's go over network automation. All right, so the whole goal of this is to do something called infrastructure as code, where we take our infrastructure, take all of our network underlay, which is going to be like our switches, our routers, our firewalls, our access points, and look at it as a consistent code base. And we have a source control management system where we can apply configuration changes all from a centralized place. So in this little example, I have an Ansible server that is running Ansible playbooks to go and automate, update, or manage all these devices at once. So instead of looking at the network as individual pieces of hardware, we look at it from a holistic view saying, okay, this is an entire code base. Now how do we make changes? Now at your level, this is like, hey, let's create VLANs. Instead of SSHing into each individual switch and configuring VLANs, we can make one Ansible playbook or one Python script to do that against hundreds or thousands of switches, okay? All at once. So real world, you guys ever done a life cycle replacement? Okay. So that's when something becomes end of life, end of service. Or even a better example, maybe something not that drastic. Has anyone ever had to apply a new CTO or a STIG to a network? All right, so essentially that's coming from top down, like from DISA for you guys, saying, hey, we got to add port security, or we got to add 802.1x to our switches to meet compliance by end of January. So you go through your systems. You're like, okay, let me check SolarWinds. It says I have 200 network switches online. Let me check my IPAM, my IP address management. All these network switches have these management addresses. Now we had to go through and add a configuration to do port security. This could be like 802.1x or something. So if you did that in the traditional manner, you'd have to go individually to all those switches. But with network automation, we can get that done with just a single script, okay? And that's what infrastructure as code is. Developing and automating tasks that are repetitive. Now with this, we start to, as network engineers, we start to develop pipelines, CI and CD pipelines, to start entering into like a DevOps kind of workflow, where we have staging areas and production networks and code changes. All right, move on. Okay. Now with network automation, we also have something called SDN, which is software-defined networking. Kind of went over this day one. That's our controller-based networking. That's where we take all of our fabric and our underlay. When I say underlay, that means like the hardware, okay? And we put all that control plane and that management plane into a centralized view or centralized server. And we call that software-defined networking. So Cisco at the enterprise has two major products that you're going to have to know about. It's Cisco Catalyst Center and Cisco SD-WAN. It used to be called Cisco DNA Center or DNAC. They just changed it this year to Catalyst Center, okay? So that Catalyst Center will sit, think about in the middle here. Underneath it all, southbound, is going to be all of our hardware. It's called SD Access, all of our hardware, all of our underlays. A lot of terms for it, okay? And from that single DNA center or Catalyst Center, we're going to configure and manage and monitor and gather telemetry on all of our physical hardware and our underlay, okay? And then north of that centralized server is going to be us, the actual network engineer or programmer that's going to interact with that GUI or use APIs and REST APIs to gather information or to set configuration on our devices. Okay, let's go over the logical planes. So the data plane we kind of already talked about. The data plane is always going to stay at that piece of hardware. Whether we implement SDN or network automation, the switch or the router is still going to take ingress traffic and send it egress. Always, right? That data plane is never going to leave the physical piece of equipment. The control plane is how we make our forwarding decisions. Now with SDN and network automation, we centralize that, right? The control plane no longer sits at the actual device. It's going to sit at our DNA center or our SD-WAN. Then our management plane, that also becomes centralized, right? Now that Catalyst Center or that SD-WAN appliance, that's going to be pushing config. That's going to be sending CLI commands to that device. Not us anymore doing SSH. We don't need to get into like all this. Okay. So I put on here software-defined networking. On the exam, you can replace this with controller-based. It means the same thing, okay? Because they're going to be asking, what's the differences between traditional versus controller-based networking? Controller-based is still software-defined networking, okay? They're synonymous. And again, the big thing is this right here, is that just everything is centralized, okay? We now have automation and orchestration with that. We build playbooks to manage our entire infrastructure. With traditional networking, you see this key word here, distributed control? You need to memorize that, okay? What we mean by that is essentially every node functions on its own. That's like a distributed control, a distributed plane. Where when software-defined networking, we need that centralized server, right? Other like keywords that you want to correlate with controller-based networking is consistency. And what I'm imagining here is on the exam they have a drag and drop where on top is traditional, on bottom is controller-based, and there's like definitions you have to drag to each one, right? So these are some of the key terms you want to know. All the upgrades in controller-based networking, they're centralized, right? Okay? Traditional networking is more complex to troubleshoot, okay? When you hear the term API, which we're going to get into what an API is, that is controller-based, application programmable interface. That's what it stands for. When you hear the terms overlay, underlay, and fabric, you need to be thinking controller-based networking or software-defined networking, okay? It's in your book too, like in the last few pages, the definitions of this. Oops. I'll give you a few seconds to write that stuff down. All right. Okay, so this is just a view of like traditional networking, what it looks like. A session for each device, doing the same config over and over and over again. Okay. So now we're going to get into, I'm going to go here and just talk about it here. Southbound versus northbound interfaces. You're going to have to memorize this for the exam, okay? Okay. So this is our network here. This is how we may architect out a network and software-defined networking. So we have our underlay here. This is going to be where all of our hardware is. Routers, switches, access points. That's our underlay. And here, we still are ingressing and egressing packets, okay? We're still going to have those like MAC address tables, things like that. They're still going to be local here. We're just not going to be going in and configuring OSPF and things like that. When our controller, so imagine this is Cisco Catalyst Center, and we're using Catalyst Center to manage our enterprise. When we want to interact, receive configuration, receive information, set configuration, manage this underlay, we use a southbound interface, okay? Southbound. So let me break this down for you. When you guys go into a router and you're typing the CLI, what protocol is allowing you to do that? Any guesses? SSH, right? You SSH that device, and you type on your keyboard here, on your terminal emulation program, like PuTTY, and that sends the command to the CLI, but that's through an SSH connection. When the controller sends configuration or asks for information, it uses a southbound interface. This at the actual, like, look at the wire, is going to be something called netcom. And it's going to be using a data structure called Yang, okay? So netcom is what a controller uses for southbound interface, all right? There's other protocols as well, but just for the CCNA, netcom. And Yang is the data structure, all right? That's talking to the actual hardware there. Something called the RESTconf can also be used. REST, like a REST API, uses HTTP, the Hypertext Transfer Protocol. So if we want to use RESTconf, at this actual hardware here, the underlay, we'd have to enable HTTPS or HTTP, okay? Now that's when the controller talks to the hardware, the southbound interface, talking to the actual hardware. Now here's us up here. This is us on the actual controller's GUI, or us, the network engineer / programmer, developing REST APIs, doing post, get, and put requests to the controller, so the controller can push that configuration down to the underlay. So here's how it kind of looks. Hold on real quick. Okay. All right. So when we're talking from controller to our application up here, or the HMI, the human machine interface, which just means you and your computer, and you're talking down to the controller, we call that a northbound interface. And here, this is going to be REST APIs. Doing REST API calls down to the controller, okay? Now, when we do a REST API, we're about to learn about this, so don't worry if you're like, I don't know what the fuck that is. Let's say we do a GET request down in the controller, and in that GET request, we want to know interface gig 00 of R1. So we'll build that REST API. We'll send that request down to the controller. The controller will send a southbound interface to request that information, bring it back up, and then respond to you, and it'll structure that response in something called JSON, okay? Or XML, but JSON is really, it's the big one. If you go to CCNP course, you'll have to know XML, but it's like never used. Maybe on old infrastructure, but. So JSON is how we'll read that information, okay? Does anyone have like any programming experience at all? Okay, you know what I'm talking about here, REST API and shit?
Not that level.
Okay. All right, that's fine. I'll say maybe if you could help me out. But sometimes in class I'll get like a guy that went to like CS in college and like knows programming really well, but anyways. All right. That's going to be it for the overview. Now, go ahead and take 10 minutes. We'll come back at 10 because we're about to get into REST APIs, and it's going to be Probably like a 40-minute lecture, okay? So take 10. And just a little note, guys, what I'm teaching you now, this is like the future of network engineering. Every single job interview has always asked me if I know how to do network automation. I didn't even see. So only 4 of you are gonna test tomorrow. That's what. Okay. That's what it says on the chat. So we'll go with. All right, now there's 5. Everybody else Saturday at 10 o'clock. Okay. All right, let's do it, guys. Okay, so now let's learn about what an API is. So we're going to go over what an API is in a traditional monolithic web architecture. So early 2000s, 2010s, when we used to build an e-commerce site, build a web server, web application, this was the architecture. Now, obviously on the network side, we'd have like load balancers, CDNs, other things like that. But from user interface, which is just your web browser right here at this PC, all the way to your web application, here's how it would flow. So when we go to access trepatech.com, we send an HTTP request. We're going to do a GET request here, okay? This is called the HTTP GET request. And that's going to hit our front end. So the front end of our web server, that's going to be everything we see. All the buttons, all the images, all the text. That's going to be formatted in HTML and CSS. So let's check this out. Come here to our courses. Everything I'm doing right now, guys, is an HTTP GET request. If I were to do a Wireshark capture on this and it was not secure, like because HTTPS won't be able to see it, but if it was HTTP, we would see all the GET requests, okay? When I click here, it's an HTTP GET request. And all this formatting is all HTML and CSS. So if I right click and hit inspect, come over here, y'all see all this body and everything here. It's just HTML. Does anyone remember MySpace? Does anyone have that? You remember doing this shit? Yeah. Anyways, all right. Okay. Now when old heads, huh? Unk status. All right, so when I click a button here, so let's say I hit this lesson. What just happened was I had a button formatted with HTML and CSS. And when I clicked that, it activated JavaScript. And that script went and talked to my back-end web server. The back end of my web server to say, hey, I now need access to this stuff right here, okay? And that's what happens when you click anything here. So all that is just interacting from now front end to back end saying, hey, I need access to this lesson here. Now, where is all this information stored? Okay? If I go let's do a quiz instead. So if I go to an exam here and continue, where are all these questions stored? That's going to be in our database. And all 3 components of our web server, from database, back end to front end, are going to be separated. They're not all going to live in a single space or container, okay? And we don't want them to. Because if we allowed users to actively interact with our database, what could happen? They could delete shit, they could add shit we don't want. We don't want that, all right? So here's what happens. If I go to click, let's say like this login button here, from the front end to back end, that's going to send a request to our back end here saying, hey, this person's trying to log in. Then the back end is going to say, okay, I need to talk to my database. But we're disconnected. So how does my back end talk to my SQL database here? We're going to have what's called a back end API, application programmable interface. And that API is going to allow us to interface with our database here, okay? Now, the database may be structured in something like SQL. So when we send that SQL information here, the backend is going to change that into JSON format. JavaScript object notation is what it's called. It's dictionary format. We have key and value pairs, and we'll have arrays and JSON objects, which I'm about to define for you guys in our next slide. Has anyone been doing the practice test? Y'all see a lot of JSON questions? Yeah, we're about to go over that. Don't expect that to be so abundant on the actual exam. Has anyone taken CCNA here recently? Okay. All right. So the back end, right, we're trying to log in. We're going to verify the information against the database. The database is going to interact with our back end via this API, and then it's going to send that information back via JSON. And this is all done through HTTPS, okay? This is all in the Hypertext Transfer Protocol. So that's the basic flow. I'm not going to go any deeper than that. But what we have to know, guys, is something called CRUD. This is all the type of operations we can do against a database. So we can create objects in our database. We can read objects, which that means like what it's going to show to us, right? We can update objects in our database or tables in our database. And we can delete. That's right. We can delete objects in our database. So these CRUD operations define how we interact with any database in the world. Whether we're using HTTP or SOAP or different API formats, because we're talking REST APIs here, which come through HTTP, okay? REST uses HTTP as the application, kind of like think of it, that's the car it drives, right? HTTP. But we have other API types like SOAP, other things like that. So when it comes to REST, though, REST operations, HTTP methods, they all have a CRUD operation. So an HTTP GET message is going to be read. An HTTP POST method, or REST API POST, is going to be create. Update is going to be put. And delete is also just delete. Fucker. There's one more we got to know about. Yeah. There's another one called patch. That's also an update. So let's go through this. So let's say on the front end, you want to update your username, okay? So in the database, we're going to have that username table. Now, that's an object in our database. If we configured it that when you update your username, it's a post, that doesn't just update the username, that's going to create a whole new object in our database. So you'll have that old username and then a brand new one in that same database, and we're going to have issues. So with the post request, that's always creating. Don't get it mixed up with put, which we're about to go over. So then we'd have two objects in here that correlate to you. We don't want that, all right? When we're just doing updates like that, what we'd want to do is send a put request. So if I give you the option to update your username, when you go and type in the new username and you hit save, what's going to happen on the back end is we're going to send, what we should do is send an HTTP put request to the back end. Then that API is going to interact with the database and say, hey, update this. Don't make a whole new one, just update the current one. Does that make sense? Okay? Let me check something. So when that happens, write this down. When we just update and we don't create a new object in our database, that's called being idempotent. I don't know how to spell it. Hold on. There we go. It's idempotent command. It just essentially means that, hey, we're interacting with a database, but we're not creating anything new. We're updating an existing object or table in there. Get is also idempotent. But post is non-idempotent. Okay, sound good, guys? Cool. Check this out. Y'all see this right here? So in my URL, that's where you do the HTTP request, by the way. Like all this post, get, put commands is all done. Like when I hit enter here, that's a GET request. HTTP GET request to this URL. That's what it responded with. When I type in secv, I send an HTTP GET request that went to my back end. It tried to do a read operation on my database. It was looking for this in the database, this name, secv, couldn't find anything. So the back end responded to me, the client, with this type of error, a 404 error, okay? So we're going to have 5 major error codes with HTTP web servers. So write this down. So I'm going to make this red. A 400 code. Make sure I get this right. That just means error though, but it's going to say client error. The reason is it pretty much just means like, hey, you typed in something that we don't have, right? So I typed in academy.trepatech.com/secv. That's my mistake, right? The database doesn't have that. So we sent you back a client error. Hey, that's a bad URL request. A 500 code, that's a server error. So pretty much that's, hey, we requested sec plus, but something happened in the database and now we can't retrieve it, okay? So it's on the server. We have 300 and 100 codes, but the next one I'm going to talk about is a 200 code. That just means success. Let's take a look at this on the wire. So check this out. You can't do this with HTTPS because the S means that it's secure from client to server. So we can't do a Wireshark capture on that. But everyone, check it out. So I'm logging into Eve. Okay. Let's do a Wireshark capture on this. We can actually look at these HTTP messages coming across. Filter this out. Okay, so I just logged in. Look at. So what I just explained, right? So this, let's not look at that. This is the GET message right here. So we see our layer 3 protocol. And we're seeing the private IP as the source because I'm doing the packet capture from my computer, right? But we know if we did this packet capture outside of our router, it'd be a public IP. Let's take a look at this. So we did a GET request, API, auth. So that's us trying to authenticate because we logged in, right? So it was authenticating our username and password. And look at all the information in here. We can see it came from a MacBook. It came from Chrome. But yeah, this is what an HTTP message looks like. And when we logged in, we got right into this lab. So all this responses are them trying to format things for us. Like, hey, here's your JSON object right here to format things. Okay? So if I, let's say, start this bad boy up, I think we still have our capture. We'll actually be able to see the telnet messages coming across here too. let's see, get API. I know I've looked at this before, but pretty much we get into the CLI, we can see the telnet messages coming across. So obviously this is what we don't like coming across the internet, right? Because someone's doing a packet capture, we can see like everything in here. But see all these 200 codes? That's the success codes. If we got an error, you would see a 400 code in there. You see it's always responding to us in JSON formatting. All right, cool. Let's move on. I think that's pretty much all I had to talk about REST APIs. Let's go over the slide deck, and I'll have you write down some notes that'll be important for the exam. Okay, so always remember our CRUD operations, guys. So you have to know that post equals create, that get equals read, that put equals update, and that delete equals delete, okay? You have to memorize that. The other update operation for REST is patch, all right? Patch. That will be something they ask you, for sure. CRUD operations. All right, HTTP. Memorize these response codes too, specifically the 400, 500, and 200 ones, okay? Hold on, I'm just going to get this. Hold on, sorry. I just want to get this. Okay, and then memorize this chart as well. This one, head, they don't really ask it on CCNA, but the rest, memorize. Okay, let's go over JSON now. This definitely will be on your exam too. You have to know how to read JSON formatting. I'll break it down for you, don't worry. It'll be easy. Okay, we need JSON because it's a data serialization format. What we mean by that is no matter what language we use to build our web servers, to build our web browsers, we can all read JSON, okay? That's all it means by a standardized data serialization, is that JSON format we can all read. So even though it's called JavaScript object notation, if our backend's Python, our front end's HTML, they all know how to interpret JSON, okay? Those programming languages. Okay, so the structure of JSON. JSON data is always going to consist of what's called key value pairs. So a key being the variable name, and then the value being the actual variable. The actual values can be strings, which are going to be in quotations. We're about to break it down, don't worry. They can be integers or numbers. It can also be Boolean logic, which means true or false. Values can also actually be another nested JSON object. So JSON objects are always going to be enclosed in curly braces. And the key value pairs within them are always separated by commas. Because you may see questions, it's like, which one is properly formatted, A, B, C, or D? You have to know, like, there's going to be one comma missing. You have to know that. And then JSON arrays are in square brackets. Let's break this one down, okay? This is exactly in this exact picture with what I'm about to write is also in your smart book too, if you go to like the back of the book. Okay, so we're interpreting JSON. So these curly braces right here, the open and corresponding close brace means we have one object here. That's one JSON object. Any questions on that? The curly brace is going to represent a JSON object. This is a key, and this is the value. Let me bring my pen, hold on. See that? It's a pair. The key, colon, its value. So interface equals gig00. It's really another way to read it, okay? So if you see a colon, the word behind the colon is always the key. Then what comes after it is the value. So this is a key value pair. And then it's separated by a comma. Tracking so far? Okay. This value, since it's in quotations right here, is a string. So this key value pair, this is a key, this is the value. You see how this is true, but there's no quotations on it? This is a Boolean, this means that it's Boolean logic. So is up is literally saying, is that interface up? Is it online? That is true. If it was turned off, that would be false, the other Boolean logic, okay? This key value pair is separated by a comma. This is a key. This is a value. Man, why do I keep missing the A? And this is a string. Why? Because the quotes separated by a comma. So look at this one right here. It's an IP address. Those are numbers, right? But is that a number or a string? String. And if you code in Python, which I think everyone should learn, at least for network automation, what I'm teaching you is the same in like Python language as well. This is also a key, but then what kind of value is this? Number or integer, okay? I'm going to not put the quotations there. I don't know why I did that. And when you're used to coding and writing scripts, you'll start to recognize like the color codeness, right? Like when you're using Visual Studio Code or any IDE of your choice, you'll start recognizing the visual patterns. But on the exam, it should be black and white, right? So you got to recognize that if you see numbers within quotes, that's a string. Why did this erase? Okay. If you see true or false, that is Boolean logic, okay? And then if you just see a number without the quotes, that's just a number or integer. Sound good, guys? Okay. It's in your book, too, what I just wrote up here. Now let's go back. Let me ask you guys a question. This may help you bring up the slide too. Let me see if I can zoom in. Oh, whatever. Okay. How many objects are in this code right here? How many JSON objects? Can y'all tell me? 4? Let's check. So curly brace, an open and curly brace pair represents an object. 1, 2, 3, 4. There's 4 objects in there. So this is one big JSON object with 3 nested JSON objects within it. Nested, okay? That's like the term. You guys, you know when you have a folder and you put folders in that folder? That's called nested folders. You go to Computer Science 101, they use terms like that, okay? You may have heard of subdirectory, subfolder, or a nested object, okay? All equally right terms. So there's 4 objects. How many arrays are there? An array is just a square bracket. This is a trick question. I'll break it down. There's only one. This right here is actually called a list. When you see 2 strings separated by a comma within these brackets, it's called a list. Okay? Now you may be wondering, so this key right here, interface underscore configs, what's its value? It's an array. Its value is an array. Because look what's right after it, right? There's the colon, that's the key, interface underscore configs. Its value is an array. And then within that array, we have 2 objects, okay? So JSON can get pretty like more in depth. And I don't think it'll go this in depth on the exam, but what you'll see on the exam is more like this. Like it'll have like 1, 2, 3, 4. And it'll be like line 2, what is the value? And then it'll be A, B, C, or D, right? And you have to pick, oh, the value of line 2 is 192.168.1.1. Make sense? Is that kind of what you've seen on the exams? Okay. Just reference your book if you can't remember. All right, cool. Let's go ahead and take a 10-minute break. Come back at 10:35, and then we're going to probably finish up for the day. We'll leave here at 11, but we'll be done. Well, I'm just going to do some review, some other things. Oh, I don't. That's up to you guys. I mean, when you should schedule them. I'll send you your vouchers, though. What's your first name again? Gil? Trippin'? You said Gideon? Dill. Fuck, okay. Where the fuck's your account at? Hold on. What email are you using? Like what? I can't find you in my shit. Hold on. Dylan. Okay. You call yourself Dill?
No.
I just misheard you?
Yes.
Okay. Dylan. Okay. Eyes. Show your friends this too. I'm gonna show you your voucher. You just go to Academy. It'll be right here, okay? Oh, what the fuck? I thought you were still behind me, bro. Come here real quick. So to get your voucher, come here. My purchases. And then hit voucher code. It'll say right there, okay?
Okay. Thank you.
What's your first name?
Aiden. Ayden.
Got you. Your boss too, right? Monroe? Okay. Ty? Do y'all want to see what we got told from Army Ignited for the people? Yeah. This is what they emailed all the vendors yesterday. Yeah, so since you guys use CC, like you already used it this year, you can't use it again. Yeah. Yeah, the Army. Well, the fiscal year already started. Yeah. Yeah, October 31st. Yeah. And you can only use it 3 times in 10 years. And they backdated it too. It's retroactive. But they upped tuition assistance by $500 and didn't put any cap on it. Pretty crazy. That's the Army, bro. I'm not surprised. Yeah, he used it at the perfect timing, dude. Yeah. That's nuts.
You make enough money to where you're paying your own tuition. Oh, by the way, we need 10 grand. That shit is so fucking stupid.
Yeah, they said the director of it said that it was a catastrophic success because too many people used it and they didn't have the budget. But then they raised TA. So I don't know.
It's still a 1,500 technical deduction for the entire thing.
Well, so it was $4,000 a year. You can get as many searches. There was no cap on the cert limit, and they renewed every year. But the budget was still from TA. Like they were always the same budget. You had $4,000 for CA and TA. It wasn't or. But now they upped it to $4,500 for TA, with no cap.
Does it still share? Does that
It still shares, yeah. It still shares. But now you can only get 3 certs for within 10 years of active service.
I bet you were happy to read that.
Well, I knew it was coming, so I just kind of was like, whatever. But yeah,
Where do you draw? I know this is kind of a common question, but
yeah.
I might have to answer it later. But where do you draw most of your profit from? Classes like these, or
Oh, it's mixed. So if I looked at my P&L, profit and loss, obviously the military, right? But I'm on a different contract with 1/12. I get a lot of money from that. GPC card purchase, I get a decent portion from that.
when they pay for the whole class with the GPC?
Yeah, and then Army CA would probably be like 3rd. But it's only like that because of like Sar McCormick setting up these big classes. But yeah, some military, and then we have corporate customers too. So like you heard of Sherpa 6?
I've heard the name Trepa.
Yeah, they're a soft contract. L3 Harris just paid us a lot. General Dynamics, Mission Training Center. We train all their guys in CompTIA and Cisco. Yeah, all the contractors. So it varies, yeah. I'm trying to be like Professor Messer though.
Yeah.
I want to make all my money just from people off the internet.
You just gotta get your website more well known.
Stickers, yeah.
I'll walk around with a Trepa in my backpack.
I do need more swag. All right, guys, we're going to finish up for the day. I want to get out of here by lunch. Got to pack all this shit up. So last thing that you might see on the exam when it comes to automation is Ansible. It's a automation tool. It uses port 22. It has playbooks, okay? Playbooks. The playbooks are what's going to configure the network devices. And Ansible is structured in YAML. Yet another markup language is what it stands for. And it's also declarative. Let me get this out of the way. All right, guys, that's it. I got nothing else for you. So, who's testing tomorrow? I don't know. I only see it when I'm in Linux and shit. Okay. Yeah. YNL? Okay, if you're testing tomorrow, guys, it'll be at my office. If you just look up Trepa Technologies on Google Maps, that's where it'll be. And then for you guys testing Saturday, tomorrow I'll just be live. I'm just going to be doing almost like a CCNA cram session, okay? Just going over from day 1 till today, all the shit, all right? All the major stuff. If you have any questions you want to review, so you're on Academy, you don't understand a question, you want me to explain it, leave a comment for you guys testing Saturday so I can go over it tomorrow during the live session. Sound good? No, it's virtual. So no, you're not coming here tomorrow. You're gonna be at your house or wherever your boss tells you to be. All right, do you have any other questions for me? All righty, y'all are good to go.